I work at the Laboratory of Geoinformation Science and Remote Sensing, and I'm involved in two projects. So one of them is the Copernicus Global Land Services project, which is intended to create a global land cover map at 100-meter resolution and updated for every year since 2015. And another one is OpenGeoHub, which is a pan-European Horizon 2020 project that is aimed at creating platform and an API to combine different cloud platforms together into one, so that we can write code for any particular platform and then reuse it for other platforms. Well, I started programming in 2009, I would say, and then since then I've been working on it on and off. I started programming more when I went to my master's, which was in 2015. And then, since then, I've been doing a lot of this geocomputation, geoscripting, and such.
Okay. And do you consider yourself more of a self-taught coder?
Yeah, I would say that at the very beginning, definitely, I was learning by myself. And I didn't even look at any tutorials. I just looked at the code, and then I was like, okay, this line sets this value, so how about if I change this value, what will be the result? And eventually I found how to change functions, because this function does something similar to what I want. How about if I copy these lines to this other function? And eventually I started writing the functions myself. It's all about geospatial data and its analysis, but it's a summer school, so it's a bit more laid back and there's more time to explain things. And for me, it's also a very nice opportunity to both talk about my work as well as to perhaps do more with lecturing, because that's something that I will need to do in the future as well. Mostly I'm using R, and in R I'm using all kinds of different things depending on what I'm trying to do. But most of my work has been focused on machine learning techniques, so I use different machine learning packages and combining them together and then seeing which one is the best and things like that. If there's something that I can just think of off the top of my head, is that maybe in that amount of time Julia would become a popular language. It has been upcoming for quite some time, and there has been some adoption, but still not that many packages around. Otherwise, yeah, hopefully GDAL will improve even further, and we will have even more interfaces from Bash that will make it easier to use, also for more complex usage than it is right now. And yeah, I think also cloud platforms will become more useful in the future, and more of them will become available, maybe also more user-friendly. And that would allow us to really try to do something with this amount of data that we have already available from all these different sensors, and combining them together also a bit more easily. Yeah, well, certainly I think one thing that is very important for open source software is that it allows people to use it no matter where they're from or what they're doing or what reason they're using it for. So indeed that means that anyone has the same opportunities to do so. I guess Google Earth Engine is also a good example of that, because you can just use it from wherever you are and use all the cloud infrastructure that Google has, which is really powerful. So I think that really can make a big difference. On the other hand, Google Earth Engine itself is not open source, which also makes it a bit tied with their infrastructure for Google. So yeah, there are trade-offs in some cases. Yeah, I think today we saw an interesting presentation about how we can model the spread of these diseases. And I think indeed I think we also saw that in the scientific community, that when the whole crisis started, a lot of people had a lot of interest to pool the knowledge together to try and figure it out as soon as possible, how it works, what to do. And I think right now the most important thing is also to give advice to the policymakers, so that they would know what things work and what things don't work, so that we are as safe as possible without that many restrictions, as much as we can. And I think indeed open source software also relates to that, because then we can share also the code, so the effort that people are making. In general, I think that would be one of the best ways to address this gap, is to do more education to show that programming is not something that is specific to any demographic. And I think this is possible, and it's kind of maybe a bit of a bandwagon effect that if we have more diversity, then it will not be so scary because it's not just the thing for those people. And I find that females are also very good at programming, just maybe a bit less confident in their skills. So as long as you show that this is not really that scary, that this is something that you can do, then the results are really good. One of the main things that I don't like about how programming is presented is that there's still a lot of misconceptions that it's related to mathematics. And I don't think that's true anymore. If you're developing algorithms that are really low level, then yes, that's true. But if nowadays we have already so many low-level algorithms implemented that for the most part it's a matter of knowing which libraries to use and how to combine them. So I think nowadays it's not so much linked to mathematics as much as to linguistics, because you really need to know how the different languages work. If you master several languages and you can combine them together with another language, like calling R and Python from Bash, then that is the way to really use the tools the most efficiently. And that has nothing to do with mathematics, and so that's not something that people should be scared of if they don't have that background.